students. So now we are about to learn the final third law of Isaac Newton, right? Here the third law is very simple, but there are some very crucial points that you need to keep in mind when you deal with this law. All right, so we'll see everything regarding that. First of all, let us see what exactly is the statement of this law, which is very simple and short, and that is for every action. Now see, whenever I say the word action, I mean force, right? So for every action, or basically force, in nature there is an equal and opposite reaction. Here reaction is also force. So basically in this universe, anywhere if I apply some force, an exactly equal but opposite force generates, and you can actually see its consequences. Alright, so we'll deal with that, but first of all let us try to understand this. Here let us see that this is a box, alright, and on this box this man is pushing onto this box. Okay, now let's say that this box is of maybe 2 kgs. If this box is of 2 kgs, it will be very easy for the boy to move this box, right? It's not that much difficult. But let's say now the weight of the box is increasing. It keeps on increasing. Initially it was 2 kg, now this is 10 kg. So he will have to put more and more effort. Later on, this weight is 100 kgs. Maybe later on, the weight is 1000 kgs. Now tell me, when the weight is 1000 kg, is it very easy for the boy to move the box? No. But remember, initially what was happening, when he was applying some force, the box was able to move, and when the box is very heavy, he is applying the force, but now box is not moving. But it is possible that when he starts to apply force, maybe because of that force, his own body moves backwards. But in this case, the direction of force, look at this. The direction of force being applied is in the forward direction, right? The boy is applying a direction of force in the forward direction, but how come his own body moves backwards? You can do this at your home as well. Just go and try to push on the wall. Be very near to the wall and try to push the wall. Wall will not move, but your body is going to move backwards. But you applied the force in the forward direction. You can also do this with push-ups, right? Get down to the floor, try to do some push-ups. You're pushing onto the ground. The earth does not move downwards, but your body moves upwards. You can do sit-ups as well, and you will see the same thing. So let's see what exactly is happening here. Let us try to apply the Newton's third law. In this case, this boy is applying a force in the forward direction like this. Okay. Here, this law says that for every force, which is your action, there is an equal and opposite reaction. This means that if there is a force in the forward direction, there must be an equal and opposite force in the backward direction like this. So here let's say that if this force is F1 and the backward force is F2, F1 and F2 are going to be equal in magnitude, right? But remember that F1 and F2 are going to be exactly opposite to each other in direction. Okay, so here this is the representation of that. And in turn, you can see that this F2 is being applied on this boy, and this is this F2, which is the reaction force which is responsible for the motion of the boy's body to move backwards. And this is the exact force which is responsible for the examples that I have given you, that is you pushing on a wall, or maybe you doing push-ups or sit-ups. And in each of the cases, this is the reaction force. Okay. Now, before we move ahead, let me ask you two very important questions. The first one is written right here, that why do not force cancel each other out? For example, here there are these two forces, they are exactly equal to each other, but they are opposite in direction. And we have learned whenever forces are equal but opposite, they cancel each other out, right? In this case, why are these two forces not cancelling each other out? All right, so we'll see the answer to that. And apart from this, another question is, tell me this action and reaction forces, right? These are two forces. Whenever there is an action force, there comes a reaction force. The question is there a time delay between action and reaction force. What do you think? Right? Do you think there is a time delay between action and reaction force, or action and reaction force occur simultaneously on the objects? All right. Now, quickly answer these questions in your own mind or maybe in your notebook, and then later on you can match it with me. All right. So first of all, let us deal with the first question, which is why forces do not cancel each other out. So let us try to understand that, and I'll give you an example here. Remember that the cases that we were studying in which forces were cancelling each other out, that was the example in which you had one boy, another boy, and both of them are applying forces on this box. Okay. Now, when these two forces are equal but opposite to each other, the box is not going to move. But tell me, these forces are being applied on what? The forces are being applied on the box, right? That means the forces are being applied on the same body. Okay? Same body. Whenever forces are being applied on the same body, it is only in that situation that you can cancel the forces, or you can add the forces, or you can do other things. Basically, take into account the direction and magnitude of forces. So basically, if you want to add any forces or subtract any forces, you can only do that when those forces are being acted on the same body. Now let us look at this example. Here, the boy is applying a force on the box, right? So that is F1. The force is being applied on what? Here, this F1 is being applied on box. But this F2 is being applied on the boy. It is not being applied on the box. So this means the two forces acting on in this particular situation are not on the same body. Instead, they are on different bodies. Okay? They are acting on different bodies. And this is the reason that you cannot cancel these two forces out. And this is the reason that in this world there is possibility of motion. Just imagine that if those two forces cancel each other out in every situation, will there be any practical motion in this world? No. Okay. So therefore, in this case, forces do not cancel. The reason behind that is as simple as that, which is the forces are being acted on different bodies. So you cannot cancel them out. All right. Forces only add up or cancel when they're acting on the same body. Okay. So here, action and reaction forces, this is the answer to the second question, they occur simultaneously. Okay. Action and reaction forces, there is zero time delay. As soon as you start to push on some object, that object in return starts to push on you as well. Okay. So this is the meaning of the second law. That means when I push on this board like this, the board in return will push on my body, and there will be a force of equal magnitude but in opposite direction on my body, as well as I am applying the force on the board as well with the equal magnitude but in the forward direction like that. Okay. All right. Now forces act on different bodies, that is why they do not cancel each other out. Okay. Even though the action and reaction forces are always equal in magnitude, these forces may not produce accelerations of equal magnitudes. See, the reason behind this is second law of motion. We learned that the rate of change of momentum is directly proportional. We learned that the rate of change of momentum is directly proportional to force. Okay. This means if the mass of the body is really high, to change the momentum of that body, you have to apply a higher amount of force. Therefore, in this case, for example, here there is a huge rock and there is this ball coming at a very high speed towards the rock. The ball is obviously going to bounce back. What do you think is going to happen in the case of this rock? Will this rock move in this backward direction? Maybe not. And the reason behind this is the mass of the rock is very high. Now, as the mass of the rock is so high, you have to have higher force, and in this case, the mass of the ball is low, right? Let's say this is the mass of the ball, which is mb. This is very low, so it requires a less amount of force. Now, in this case, when the ball hits on this, what is going to happen? The ball applies a force in this direction onto this rock, right? Let's say that is force Fb on this rock. In this case, the rock in return is going to apply an equal but opposite force on the ball. Let's say that is Fr, right? This is the force applied by the rock on this ball. This will happen only when the two objects are being in contact with each other and the ball now bounces back, right? Now this force and this force is going to be equal to each other but exactly opposite in direction. You can clearly see that this small Fb is going to have almost zero effect on this rock because its mass is so large. So this small amount of force will do nothing on this rock, but this same amount of force on this ball acting in the opposite direction will result in the bouncing back of the ball because its mass is less. That means its inertia is less. We can apply less amount of force to just change the momentum of the ball. Alright, so this is the reason that equal and opposite forces are acting on almost different cases in different scenarios, but some objects move and some objects do not move, and the reason behind that is the mass of the object. So if the mass of the object is high, its inertia is high, so the force required to move that object is also different. Alright, so here we are going to see the practical applications of the third law of motion. Okay, remember that the third law was every action has an equal and opposite reaction. In this case, if I have a balloon and I open this side of the balloon, the air is obviously going to come out. But we usually see that the balloon goes zigzag. It goes usually in the upward direction and it goes randomly. Why is the balloon going upwards? See, the balloon is basically pushing the air outwards. As a result, the balloon is applying outward force on this air, right? We know that according to Newton's third law, this air is bound to push the balloon in the upward direction. Remember, every action has an equal and opposite reaction. So this, let's say, is action and this is going to be the reaction. Remember, there is no time delay in action and reaction. They happen simultaneously. Okay, so in this case, what exactly is going on? The balloon will suddenly move upwards. Now remember that air is chaotic, so here the direction of forces keep on changing. As a result, the balloon goes in random direction. But remember, each time, whatever is the direction of force applied by the balloon on air, the air in turn applies equal but opposite force on the balloon. The same thing is done in this case as well, that if a man wants to jump out of a boat onto the land, what he is doing is he's applying a backward force on this boat. Okay, he basically applies a backward force on this boat. As a result, now this boat is going to apply a forward force on this man. All right, and it is this force which makes the man move in the forward direction and he can now jump out of the boat. Here we can see that in the case of recoil of the gun. All right, now usually in movies or maybe in some video games, you might have seen whenever a gun is fired, mainly the gun recoils a little bit backwards. What is the reason behind that? See, actually, as soon as the bullet comes out of the barrel of the gun, what exactly happens is this gun, because of this, here this bullet is moving in the forward direction. That is, the gun applied a force on this bullet in this direction. Now, when the bullet was leaving the gun, in that case, the bullet in turn applies a backward force on the gun, right? Newton's third law. And it is this force which is responsible for the motion of the gun. In the backward direction, it gives the recoil. See, keep in mind that the mass of the gun is way higher as compared to the mass of the bullet. As a result, the bullet, due to application of some amount of force, it can move with a very high velocity in the forward direction, but the mass of the gun is very high, so the same and equal but opposite force is applied on the gun, but that force is not large enough for a very high change in velocity of the gun. That is why it recoils, but obviously the velocity of the gun of recoil is going to be a lot less as compared to the velocity of bullet. Propulsion of a rocket. In this case as well, you can clearly see that basically this is the jet rocket, and in this case its exhaust is in the downward direction. Alright, so it pushes the gases downwards, and in return these gases push the rocket in the upward direction like this. And this is the reason that a rocket can be propelled in the forward direction. Alright, so these are some simple examples of the Newton's third law of motion.